Lesson done. Physics. Forces. Energy, speed, calculations on that. Resultant force. The resultant force causes the acceleration. Very important to say resultant force causes the acceleration, because that way you will remember that if you're making a calculation and there are several forces, or there are two opposing forces, for there to be an acceleration, there has to be a resultant force which is different from zero. If the resultant force is zero, then there is no acceleration. So there can only be either of two things. Either the vehicle or the object is stationary, or it is moving at a constant speed. So what does constant speed mean? So for example, if you're told that a vehicle has a forward force of 800 newtons and an opposing force of 800 newtons, that means that the resultant force acting on the vehicle is zero. If the resultant force is zero, but there is a forward force of 800, that means that the car is actually in motion, but it is not accelerating. Because if it is accelerating, it means that the forward force is greater. So because the forward force is the same as the opposing force, there is no acceleration. And without an acceleration, but still a force being applied in the forward direction, there is movement. But it is movement without acceleration, because the resultant force is zero. Okay? So bear that in mind, that you need a resultant force if the object is said to be accelerating, or is going to accelerate, or is accelerating. Okay. So that's that. Then the other thing is you need to know the equation for motion. So the first equation says V equals U plus AT. So you need to know what V is. So V is the final velocity, is equal to U, the initial velocity, plus A and T, the time. So V equals U plus AT. And then V squared is equal to U squared plus 2AF, which means final velocity squared is equal to the initial velocity squared, or the square of the initial velocity, plus the product of the acceleration and the distance times 2, or double the product of the acceleration and the distance. But in this case, distance is, we say distance is f and not d. Because if we're going to multiply distance over time, s equals d over t. In this case, the distance is d and the speed is f. You see how f is the speed, for speed equals distance over time, but f is the distance, for f equals ut plus half at squared, which is the third equation, or v squared equals u squared plus 2af. Okay, so the third equation is f, the distance, equals ut, initial velocity times time, plus half the acceleration times the square of the speed of the at squared, the square of the time. So half at squared, f equals to ut plus half at squared. Then the other important equation, which is the resultant force, F equals ma. F equals m times a. Force equals mass times acceleration. But acceleration can also be A equals V minus U divided by T. From the equation V equals U plus AT, you can make A the subject of formula, so it becomes A equals V minus U over T. So F equals MA becomes F equals M open bracket V minus U close bracket over T. Okay? If you multiply both sides by T, you get Ft, which is impulse. Ft equals mv minus u. But mv is momentum, and mu is initial momentum. So the impulse is actually the change in momentum. The impulse is change in momentum. Okay? I think that's it for now. If you have any questions, please do let me know. I will be happy to answer your questions, either in the comments or with another video. If the comments, if doing that in the comments alone will not be enough, I can do that. Make another video.